On 57, we're asked to find all of the zeros for p of x, which is a sixth degree polynomial with lots of terms. Now, because of how big this is, I definitely don't know a way to factor this, and I don't expect you to either. So let's start by finding our possible rational zeros. So we look at all the factors of the last term, 24, so that would be 1, 2, 3, 4, 6, 8, 12, and 24. Those are all the numbers that go into the last term, over all the factors of the first coefficient, 3. 1 and 3. Now, if I do every possible pairing here, I've got a lot. 1, 2, 3, 4, 6, 8, 12, 24. That's if the denominator is 1. If the denominator is 3, I can add on 1/3, 2/3, 4/3, and 8/3. So I've got a lot of possibilities for my possible rational zeros. So what I want to do is I want to start going through my synthetic division and seeing which ones actually give me 0. So let's go through this. 1, 3, -10, -29, 34, 50, -24, -24. Go through your synthetic division. And we find a 0. Because we get a remainder of 0, this is a 0. If the 0 is 1, the factor for that is x minus 1. And our quotient is what's left over here. And remember, when we do synthetic division, it knocks it down a power. So if we start at x to the 6th, this is going to be 3x to the 5th minus 7x to the 4th minus 36x cubed minus 2x squared plus 48x plus 24. Now we need to knock that down even more. So I'm going to look at what I have written in red there and continue doing synthetic division on that. Now remember, you should always check the one you did before because it could be a multiple root. So I'm going to check 1 again, but I'm going to do it with the red numbers. Let's do our synthetic division. Okay, 1 doesn't work, so let's move on to -1. All right, -1 works, so that's good. So 1 was or x minus 1 was a factor. Because -1 was in the box, x plus 1 is a factor because it's the opposite sign. And then this yellow quotient here is what's left. Keeping in mind that it knocks it down a power. So this is now going to start to the 4th power. So this one's going to take a decent amount of time because we want to keep getting it down, down, down until we have a quadratic we can either factor or use quadratic formula for. Now you usually want to test -1 again, and we would. And as you go through these, because of all the possibilities, this one can end up taking a while. So I'm going to go ahead and just tell you that the next one you'll want to try is -2 with what you have left over, the red numbers. But you would pick up with -1, that wouldn't work, 1 wouldn't work, or sorry, 2 wouldn't work, but -2 should. Yeah, -2 works. So one of my factors is x plus 2, x minus 1, x plus 1, x plus 2. And I'm left with 3x cubed minus 16x squared plus 6x plus 12. All right. Now, you can continue to go through this. You're going to get a lot of kind of dead ends when you try and do it. But I believe if you do 2/3, it works out. sorry, negative 2/3. With what's left in the parentheses there. And so you end up getting the negative 2/3 is a 0 because we got our remainder of 0. So finally, down here, we get x minus 1, x plus 1, x plus 2, x plus 2/3, and we're left with 3x squared minus 18x plus 18 equals 0. Now notice with this that's left over that I'm underlining, I can pull a 3 out of that. Pull a 3 out of that. I can set each of these equal to 0. If I set 3 equal to 0, there's no solution. X minus 1 equals 0 means x equals 1. X equals negative 1. X equals negative 2. X equals negative 2/3. With what's remaining, I have to use quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. (36 minus 24 over 2). It's the square root of 12 over 2. Square root of 12, if you simplify that, is 2 root 3. Sorry, over 2. You can pull a 2 out of the top. They cancel, and you get 3 plus or minus root 3 as your other two zeros.